Hi, this video will discuss two items. First, we'll talk about long-run production. And second, we'll discuss isoquants, show you what they are, and explain how you graph an isoquant. First, a long-run production. What is this? This is the time period when you can adjust all your inputs. So both labor and capital are considered to be variable or can be adjusted. Since you can adjust both your capital and your labor, it's possible now to substitute capital for labor or labor for capital while keeping your output unchanged or constant. So that was long-run production. Now let's talk about isoquants. Isoquant, what is it? It's a curve that's going to show you the efficient combinations of both labor and capital while keeping your output unchanged or the same. So iso means same, quant represents quantity, so we're talking about same quantities here. Different combinations of inputs, capital and labor, that get you the same quantity. There's an equation for an isoquant. And this equation is as follows. Mathematically, we would represent an isoquant as your output Q, which is not changing, it's constant, so there's a bar on top of it, is equal to a function of your inputs, labor and capital. So you can adjust both labor and capital while keeping your output unchanged. For example, this may be a specific functional form. Q is equal to 2 times K times L. And maybe the firm wants to know what are the different input combinations, capital and labor, that they can use to get 16 units of output. So let's think about this. Can you come up with a combination of capital and labor that gets you 16 units of output? What if you had a single machine? How much capital, well, you had one machine, you have 1 unit of capital. How much labor do you need to come up with 16? Well, you would need 8 workers then. What if you had 2 machines? Well, if you had 2 machines, you could use fewer workers, right? So you'd have 2 times 2 is 4. You want to get to 16, so now, of course, you would need 4 more workers. What's another way you could get 16 units of output? Well, our capital could be now 4. If our capital is 4, we have 2 times 4 is 8 times how much labor gets us 16. Yes, that's correct. You would need 2 more workers to get you, 2 workers to get you output of 16. Finally, if you had 8 units of capital, 8 machines, well, 8 times 2 is 16 already, so you just need 1 worker then to multiply that to get your 16. So these are 4 different ways you could get an isoquant of 16. So let's show that isoquant in the next graph. Okay, so on the next graph then, we would have an output of 16 and various combinations that provide the same level of output. So here is a family of isoquants. These numbers correspond to data represented in this image here between labor and capital. Okay? And for example, 24, you could get 24 units of output, an isoquant of 24, using 6 machines and 1 worker, or 3 machines and 2 workers, or 2 machines and 3 workers, or finally 6 and 1 combination. And that's what's sketched here, one output of 24. So these are different isoquants. Isoquants here never intersect. Isoquants here, there's an infinite number of different isoquants. The further you get from the origin, the larger the output the isoquant represents. So this is a family of isoquants have the downward slope. So properties then of isoquants, the further from the isoquant is from the origin, the higher the level output we're talking about. The second property of isoquants, they will never intersect. The third property of isoquants, they're always going to slope downward.